So in this particular video, we are going to do some hands-on on table. So we'll be doing some table operations, like we'll run some selects, updates, inserts are something that we have already discussed. I'll not be running inserts as much, but I'll show you some insert statements. Then also show you delete statements and then table joins. Followed by that, we'll use or I'll show you create table as statement, using which you can create a table as per an existing table along with its data. Now after that, we'll see view. So before going into the hands-on of view, what a view is. View actually stores a complex select statement. So remember, it stores a select statement. It does not store the result, right? So let's see what that means. So let's say I have this select statement, select a dot c1, c1 is column, b dot column 1 from, let's say, 4 tables, t1, t2, t3, t4. The alias of these tables are a, b, c, and d. So when I say a dot c1, that is actually t1 dot c1, and when I say b dot c1, that is t2 dot c1. You already know what this is if you have gone through the optional SQL basics session. Now after that, I'm mentioning some where clause, and I'm actually joining these 4 tables. Now it can be a very large complex SQL statement, and you do not want to run this SQL statement as a whole. Instead of that, you want to create a view. So how do you create a view? It's very simple. You create a view on top of it by preceding the select statement with create view statement. So if you see, I have mentioned create view v1 as, followed by the entire select statement here. So this entire select statement has been put here, and then I'm creating a view on top of it. So now this view v1 would be created, which would actually be this select statement. Now if I have to run this entire select statement, what I have to do is I'll have to run a select star from v1. Of course, you can select only a few columns from this view also. Now what will happen behind the scenes, whenever we run this select statement from this particular view, the SQL statement that is there in that view will be executed. So the view will not store any results. Remember that is important. So view will store only the definition of the select statement. It will not store any data. So whenever we run this view, whenever we query this view, this select statement would run and then give us the result. Let us go ahead and see some hands-on. Now what I have done is, the tables that I had created, I have loaded those tables using this copy command. I have run this copy commands already. So what these copy commands are doing, these are loading data which are there from CSV files which are there in the S3 buckets, right? So retail products, retail sellers, etc. Now don't worry about it. We'll talk about copy statement in detail later on. So I'll be running DML statement here, and now let me go back to dark mode, and these are the tables that I was showing you, and those tables are actually have been created in retail schema. So I will set the search path to retail. So now if I run queries, I do not have to mention the schema all the time. So let's do a select count star from customers. So it will show me how many records are there. So it is around table. So let's see how many are there in order items. So order items has 225,000 records. So again, these are the tables. So let me go back to the DDL query that I was showing you, which I used to create the table. So I have this customers table. The primary key is customer ID. We have orders table. So orders table is referencing customer table, but the order item table is actually referencing multiple tables, right? So I have this order items table, which is referencing products table and sellers table rather. I want to find out that which customers place these orders, right? So I want the order ID and what product ID the customer created, what was the price of the order, and then also the seller address. So I just want to find out the seller zip code, let's say, and let's say some product details like product category name, and the customer details. So if I go to the customer information, so I have this customer detail. I do not have customer name. Again, this is just a hands-on session. Does not have to have all the business significance. So now this is what I'm going to do. So I'll be selecting the order, its corresponding customer detail, the seller detail, and the product that was bought in that order, product category, right? So let's do that. So how do I do that? So let me go and let me run this query here itself in query editor v2. So I'll run a select statement. Now what I want to do is that I want to select from multiple tables. So I have order underscore items table. So I'll alias it with, let's say, OT or OI rather. Sellers, I'll alias it with S. Then products with P, orders as O, and customers with C. Right, so these are the aliases. Okay. Now what I want to do is that I will want to select. So this is the query, and we can run this query. Of course, it will show me the result. Now I can see only 100 records because I have limit. I put a limit here. It will show me 100 records. It will fetch 100 all the records and show me 100 records. So if you see, these are the records that I have. Now what I can do is I can create a view on top of it. Let's say I name the view as order details and as. So now if I execute this, it will not return the output. It will return a success statement that the view has been created. So if you see, the view has been created. It took around 77 milliseconds. I'll come back to these things later on. Now if I do a refresh, in the retail schema, one view got created, which is order details. Now I can run a select star from order details. So this is the view that I was talking about. Now if I run this, it will essentially run the select statement. It is not storing anything, it is running the select statement. We got it fast this time because the result was cached by Redshift automatically. Redshift does something called result caching, which we'll talk about later on. So that's why I got the the result pretty fast. But anyway, if I do a select star from order details, it is showing me the output, the same output as it was showing in the previous case. And from here, I can select, let's say, just order ID and price. So if I run this, again, it is running the select statement behind the scenes. And from that select statement, it is getting the output result. And from that output result, it is just showing me order ID and price. So if you see on this particular view, I can actually select only a few columns. Sometimes it might happen that you want to select only a few columns. In those cases, you can select only the columns from the view. Okay, so now let us run some update and delete statements. So now what am I doing is I am updating this customer where the customer ID is this particular value. First, let me select this particular customer. So there are two customers. I had loaded it twice, sorry. So again, you see that even though customer ID is the primary key, Redshift not enforcing it. So the zip code is 797340, and I'm going to update it to 2208. So if I run this query, the update is done, and if I run the select statement again, of course the record would be updated with the zip code as 2208. Now both the records would be updated. So if you see, both the customer records have been updated, right? So this is how an update statement looks like. You can update one column or multiple columns, and you can update all the columns. So if you, let's say, remove the where customer ID, then all the zip code for this particular table, all the customers will have the zip code 2208 because you are not mentioning any where clause. So now let's delete a customer. Now I have two rows for this particular customer, and I want to delete this customer. So delete from customers where customer ID equal to the value. So if I run this delete statement, of course both the rows would be deleted. So this operation is done. If I run this, I should not be able to see any output. As you can see that the operations, the SQL statements are absolutely similar. So these are NC SQL. The update, select, insert, delete, join, etc. would be same in all the databases that you can think of, DB2, Oracle, SQL Server, Postgres, MySQL, Redshift also, and again Teradata also, so other data warehousing environments as well. Now let me try to run some joins. So I have already shown you the inner join using this particular statement. So here we did inner join of 5 tables, right? So order items, sellers, products, orders, and customers. So we joined 5 different tables using inner join. So let me go ahead and try to do some left outer join and then right outer join. We'll join the order items table and the sellers table. So what we'll do is select, so I will select order item dot seller ID, and from seller I would select seller city and then seller state. Okay, so now what I want to do is that I want to do a right join with sellers on the seller ID column. Why? I want to see whether there are sellers which are there in the sellers table but not in other order items table. So let's do items dot seller ID and sellers dot seller ID. So this is a right join, again similar to the SQL statement that we have already seen. I can see only 100 records. The number of records are very high here. So it seems like all the sellers are there. So this is right join. If you want, you can do a left join also to find out if there are order items which does not have a seller. Should not be the case, but I'm just showing you an SQL statement. Right, so again, it will not be the case, but yes, of course, we can get some output. So these are the typical table operations that we'll do. We'll run very complex SQL queries on Redshift. We'll seldom run update and delete statement. The number of write statements that will run in Redshift would be much smaller than the select statement because it is mainly for analytical processing and data warehousing processing, not for OLTP stores. So the number of writes to the database would be much smaller compared to reads. So that's all about table operations. Now let's get into an interesting part, which is transactions.